Welcome back, everyone. Today we're going to learn about sequences. What is a sequence to you?
You can say it.
A bunch of
numbers
yeah,
that like just continue on going.
and there's like a pattern to the numbers. Thank you. Today, let's start with introducing sequences.
A sequence can be defined as an enumerated collection of objects in which repetitions are allowed and order matters. In mathematics, objects are just things that's been formally defined or things that can be formally defined. In other words, sequences are just some numbers placed in some order so that they have a correlation. So there are two main types of sequences that we will be briefly talking about in this video. The arithmetic sequence, which is when each term increases by a common difference, and the geometric sequence is when each term is increased by a common ratio.
Moving on to part 2, arithmetic sequences.
For the arithmetic sequence, it's essentially when each term is defined by adding a fixed value to the previous term. To define the term, well, a sequence starts at its first term, which we usually refer to as U1. Then it builds on U1. After U1 you have U2, after U2 you have U3. In an arithmetic sequence, U2 is defined as U1 plus a common difference, and U3 is U2 plus a common difference. You can also view this as U3 is U1 plus 2 of the same common difference.
To understand this even better, we can look at an example. As you can see, there is one pen, which is U1, so U1 is 1. The difference of the sequence is 2, which you can see from the two highlighters on the table. From here we can see U1 on the left, and then there is U2 on the right. U2 is U1 and the difference added together, which gives U3. This is Eden, our first term of the sequence. This is Karen, and her combined with Eden makes the second term. And here is Irene, making our third term equal to 3. Welcome, Carolyn. Now she is the fourth term. Hi, Mr. Plachkich. Now we know that our fifth term is equal to 5. Here's an example of a sequence, with U1 being 2 and the difference being 3. As you can see, the numbers add up by 3 for each increasing term. A common question in sequences is finding the value of a certain term, and you can use the formula highlighted in yellow here. So, for example, find the term 25, and you just input the numbers into this formula. So in this case, it would be 2 plus 25 minus 1 times 3, which equals to 74, giving us the result. Now let's move on to learning about series and sigma notation. A series refers to the sum of the terms in a sequence. Let's take a look at the sequence example that we used previously. Instead of finding out what term is what value, in a series, we find out what these values added up together would equal to. A series is the sum of terms in a sequence. The sigma notation represents the series of a sequence, and it is often represented by the symbol as you can see on the screen. So, the top of a sigma notation would be the beginning term, and then the bottom would be the total term that your series can go up to. Now, using an example with actual numbers, which is the same one we used to find the first 25 terms before, now we're going to find the series of this sequence. As you can see on the sigma notation, the top would be n equals 1, which is the first number that you can input on the formula next to the sigma notation, and the bottom would be 25, which is the highest term of this sequence. After inputting this in the formula and calculating all the sums, you should be able to gain the final series of this sequence. Now let's take a look at how sequences can be applied in real life. Our first example would be financial planning and budgeting. So when we allocate a fixed amount of money to savings or debt repayment every month, we create a sequence. This approach allows us to track our progress, achieve financial goals, and maintain a balanced budget. For our next example, consider a growing population in the city. The increase in the number of residents over time can be modeled by a sequence. This knowledge can help urban planners, policymakers, and also infrastructure developers in managing resources, ensuring sustainable growth, and also providing good quality services. Quick recap of today's lesson. So first of all, we introduced sequences and also arithmetic sequences. Then we went on to series and sums of sequences. And lastly, real-world examples of how sequences are useful in daily life. Shout out to Irene, Carolyn, Eden, and Karen for starring in our YouTube video. And of course to Mr. Plachkich for teaching us all this content. Thank you so much for watching. See you guys next time.